Alright, trig class, we're going to look at this equation that contains a cosine function, but it has an altered interior. Stuff on the inside of the cosine has been altered, so we're solving for this theta right here, but we need to deal with the fact that all of this stuff is inside cosine. So the thing we have to remember is cosine is the x-coordinate of these unit circles. Okay, we're also in the 0 to 2 pi, so over here that means that we're going all the way around this unit circle when we're looking for these angles. Alright, we need to find where is cosine equal to 1. That's the x-coordinates being equal to 1, and it only happens right here when the angle is 0, okay, 0 radians. Now it also would happen if we went all the way around and added 2 pi radians or subtracted 2 pi radians. So we're going to set it equal to 0 plus 2 pi times k, because again we could just go over and over and over again. Now this is not a general solution, this is in a region, but we do need to do this when the inside function has been altered. Okay, so again what we're doing here is we are the stuff inside a trig function are angles. We can think of this as an angle. Angle required to make cosine, which are the x-coordinates, equal to 1 is this angle measure on the unit circle. It makes the x-coordinate 1. So we're setting all the stuff that's in the place of the angle equal to that angle. That's what this is. But because I could go around over and over again in the positive or negative direction, I add this piece to it, and that allows me to go around over and over and over again. So there's the equation we need to solve. When I add the pi over 2 over, this has a k in it. These are not like terms. So I'd have 2 theta equals, adding pi over 2 would get rid of it here, but I would add it to that 0, right? Meaning again, that does not have a k in it. The 0 doesn't. This does. So I add the pi over 2 to the 0, but not to the 2 pi. So now this is pi over 2 plus 2 pi times k. But when I divide by 2 to get theta by itself, I do need to divide both of these pieces by 2. So theta, the number in front of it cancels away completely. That's what we're after, is isolating theta. Pi over 2 divided by 2 is pi over 4, and then 2 pi times k divided by 2. The 2's would cancel there as well, and just give me pi times k. So what this means is, again, between 0 and 2 pi over 4 works, but then if I add pi over 4 plus pi would be like 4 pi over 4. It would be like what I'm adding, since we have a denominator of 4. So 4 pi over 4 plus pi over 4 is 5 pi over 4. And then if I added 4 pi over 4 again, I would have 9 pi over 4. 9/4 is greater than 2 pi, so we don't want that one. So these are our two angles that would work. So I'm going to do a pi over 4 comma 5 pi over 4. So there's my two solutions that work in that region 0 to 2 pi.